last class, you guys, unbelievable. Thank you for coming. So you have officially been here for 15 weeks via Zoom. So yeah, you did it. So what we're going to do today is we're going to finish up the last two reviews. I did post the solutions to the reviews that we did. So if you and the video, I did post the video too. But if you just want to look at the solutions so that you can continue to practice, I posted those, and then I've also posted, or I will post the solutions to what we're going to do today. So in case we run out of time, in case we don't have enough time to go through every single one, then you'll have all the answers in the Canvas module. And it's down at the bottom of module 4 under final review materials or final review information, something like that. So so you will have all the answers that you need. As far as the final goes, I know that your My Math Lab final review, that's your homework, I don't know which one it is, homework 21, I think it is. Yeah, 21. That is for a grade, and it is unlimited access. But if you want to know where to spend most of your time, I would say spend it on the paper or the paper reviews that I have in the module. And I do drop 2 low homeworks and 1 low quiz score. So so if the My Math Lab review is just, you just didn't get to it, or it's not working the way that you want it to for you, I want it to work well for you. So so if you can get it done, great. It's unlimited access. You can go and come as much as possible. Otherwise, really spend time on the final review, because that will give you a really good indicator of what's going to be on the final. So since this is our very last class, remember our final is on Tuesday at 11, so just like normal. And then it's timed, and it's 180 minutes as opposed to 120 minutes. So there's 20 questions, and I'll do like I did before, where I'll post it. I'll post the final exam 15 minutes before class starts. So at 11:45, you can get in there and you can print it up, which is always the easiest. You print it, you do all the work on it like you're taking a paper test, and then you submit it, upload and submit it. That's the easiest. If you have to write it, if you have to use separate paper, I would say don't rewrite the question. Just make sure you number each one. So, number 1, circle it, and then do the work. You don't need to rewrite the question. Just show me your work. And then again, you're going to scan it, upload it, and then that's how I will grade it. And you can use, make sure you have a calculator, handheld calculator. Don't use the computer one. And then I would very much limit the number of notes. So don't just bring your notebook that you've had all semester. Don't bring that to it. Just as you're doing the review, just write yourself some notes to, to see what it is that you need notes on. So you should only bring notes that you actually need, because I don't want you to waste your time flipping through your notes trying to find the information that you think you need. You should have all of that ready to go before you even open the final. Okay, so any questions on the final?
No.
Okay. Oh, okay. Okay. All right. So I'm going to share my screen one last time. Oh, that is not what I want to share. There it is. Okay, so this again is from our OneNote, and I do apologize that I was never able to get it to work. The way that they, IT, they're always trying to do the next best thing, and for whatever reason, from last semester to this semester, the Canvas will not support OneNote. So I need to figure out another way to do this. Okay, so here we go. So this is chapter 11. So chapter 11, remember, was the optimization chapters. And so what we're going to do is we're going to start with remembering what and why we do first derivative. So when you look at this graph, what we're looking for is when we're working with first derivative, we're looking for slope. So first derivative is we're looking for the slope. We're looking for max and or min, and we're looking for where is the slope increasing or decreasing. Okay, so if you see any of these terms, then you know you're going to do first derivative. Another term that is also part of first derivative is critical points or critical numbers. Okay, so if you see the term critical numbers, so like right here, that is your indicator that we are doing first derivative. Okay, so the first thing you're going to do, and then it says determine where the intervals decreasing and where are they increasing. So for this particular one, all you're going to have to do is find the derivative. So 4 times 3 is 12, x cubed. 24 times 2 is 48x. And then you're going to set that derivative to 0. And then you're going to solve for x. So for this one, I can factor out a 12x, and I end up with x squared minus 4. Okay, and again, the reason why we're setting the derivative to 0 is because we are looking, where is my derivative or where is my slope hitting 0? So remember, 0 means it is a horizontal line. So when my slope hits 0, that means something happens. Something critical happens, and that's why they're called critical points. Okay, so then this one, this x squared minus 4 is the difference of two squares. So I'm going to factor it. X plus 2, x minus 2 equals 0. And now I can solve for my critical points. So x equals 0, -2, and 2. So remember, if I have 3 x's, I'm going to have 3 critical points. Okay, so now once you do that, then you're going to set up your test chart. And we're going to look at it in terms of the first derivative. Okay, so we're looking in the intervals. So now we're just going to test. We're just going to test it. So because we're testing first derivative, I'm looking right here at the 12x, x plus 2, x minus 2. And so if you remember, you're looking for any number in this interval, so any number less than -2, so I'll pick -3. I could have picked -10, -100, doesn't matter. Any number in this interval is going to give me the same values. All right, so this is where, because I'm looking for slope, all I'm wondering is it positive or negative? Is it increasing or decreasing? So all I have to do is look at the signs of these 3 parts. So when I do 12 times -3, I get a negative value. When I plug in -3 plus 2, I get a negative value. And -3 minus 2, I get a negative value. So a negative times a negative times a negative makes the whole thing negative. So in that interval, in this first interval, I have a slope that goes downhill. Now, I included the graphs just so that you could see it, so that you have a visual. All right, you're not going to have to graph these on the test, I don't believe. I made the test, but I can't remember if I'm having you graph them or not. All right. And now I'm going to do the interval between -2 and 0. And again, don't use the critical points, because the critical points is how we got 0. So we want to use values between these two. So I'll use -1. So 12 times -1 is negative. -1 plus 2 is a positive. And -1 minus 2 is a negative. So a negative times a positive times a negative makes that whole thing positive. So in this interval, it goes up, which it shows, right? So this was negative, This is positive. So the next one should be negative. Okay. So between 0 and 2, so I'll pick 1. So 12 times 1 is positive. 1 plus 2 is positive, and 1 minus 2 is negative. So that makes that whole thing negative. Okay, so again, when we're looking at first derivative, I don't care about the value, right? I don't care about the value. All I care about is my slope increasing or decreasing? And that's what I'm testing, is the slope increasing or decreasing? And then my last interval, I'll say positive 3. So 12 times 3 is positive. 3 plus 2 is positive, and 3 minus 2 is also positive. So the whole thing is positive. And it matches my graph. Okay, so I have a negative slope, a positive slope, a negative slope, and a positive slope. So what that tells me is that my my maximum is at 0, and my minimum, I have 2 of them in this case. I have 2 minimums, 2 low points, and they're going to be at the same value. All right, now for this particular question, it doesn't ask what is the maximum and minimum. Okay, all it's asking for is where is it decreasing and increasing? Where are the intervals decreasing and increasing? So I have all my information right here. So I know that my intervals are increasing from -2 to 0 and from 2 to infinity. So here and here. And then it's decreasing from -infinity to -2 and from 0 to 2. Okay, so for this particular question, this is my answer. All right, now if it asked for what is the maximum and minimum, if it asks that question, then I'm going to take this information and go, okay, if my minimum is at -2 and 2, I have to plug this back into my original function, not the derivative, because I'm not talking about slope anymore. I'm talking about what's the actual value. So when I plug in -2, I get -2 to the 4th, which is 16 times 3, which is 48, and then 24 times -2 squared. And make sure that you use parentheses when you're dealing with negatives. Otherwise, your calculator could calculate incorrectly. So 48 minus 96 plus 7. So my minimum is at -41. And I can see right here and here, that looks pretty accurate, right? 40 is here, so -41 is here. So then I'm going to do the same thing with my +2, and I'm going to end up with the exact same values. So -41, which fits my graph. So this is my minimum. And then my maximum happens at 0. So when I plug 0 in here, 0, 0, plus 7. So my maximum is at 0, 7. Okay, so if it asks for this, I wanted to make sure that you have both scenarios. I think on one of the tests, it asks for maximum and minimum, and I had several students just give me the X value of the maximum or minimum. That just tells me where is it graphically, but it doesn't tell me, or horizontally, but it doesn't tell me where it is up and down. So you have to, if it asks for the actual maximum, you have to find the Y value using the original function. Okay, everyone good with that one? And this should all be review, right? It should be, oh, that's right. And then off and running again. Okay. All right, so second derivative, we're looking for some different points or different terms. So second derivative indicates curvature or concavity or inflection points, okay, which we call POI, points of inflection. All right, so again, what that means is, where is it curving? So if this is the graph, you can see it's curving up and then down and then up again. So for inflection points, you have to find the second derivative. So you have to walk through the process of finding the first derivative. And then you jump to the second derivative, because it's not asking me to do anything with the first derivative. It's saying, what's the inflection point? So I have to get it to the second derivative. Okay, and then the same exact process that we just did. We're going to take the second derivative. We're going to factor out a 12. We're going to set that second derivative to 0. I'm going to factor. So again, remember, factoring always comes to jump in at any given moment. Okay, so factors of +4 are -4 times -1. When I add those, I get -5. So that's how I got those. Okay, so now I have my possible points of inflection. So my x is going to equal +4 or 1. Okay, so just like before, we set our second derivative to 0. We solve for x, and these are our possible points of inflection. Now I'm going to make my test chart for the second derivative. Okay, so the second derivative, I have between 1 and 4. So in this interval, I'm looking for the second derivative of, say, 0, any number less than 1. So again, I'm going to use these set of terms right here. So 12 is positive. Make sure doesn't look like a negative. 12 is positive. 0 minus 4 is negative. And 0 minus 1 is also negative. So that means that is an increasing or positive curvature. So notice the second derivative, I don't use arrows, I use curves because I'm curving up. It's a positive curve. And then for the middle is, I'll say 2. So 12 is positive. 2 minus 4 is negative. 2 minus 1 is positive. So this is a negative curvature. So it curves down. Okay, and so far it's following my graph. And then values bigger than 4, say 5. I have a positive 12. 5 minus 4 is positive. 5 minus 1 is positive. So the whole thing is positive. Okay, so once I see their opposite, positive, negative, this is a actual point of inflection. Negative to positive, this is also a point of inflection. So now I'm looking for the actual inflection points. So I have to find out where exactly do the inflection points fit. So we're going to plug in 1 into our original. Always go back to the original to find out where it actually is. And just to save time, when I plug 1 into the original function, I get out a 23. When I plug 4 into the original, I get out 17. Okay, so what does that mean on the graph? So when you look at the graph, remember the points of inflection is, where does it curve from down to up? Well, at 1, right about here, 123, you can see it's curving up, and then it switches and starts curving down. And then at 417, I don't know, right about here, right? Now it went from down and then it started curving up again. Okay, so that's where our points of inflection happen. Okay. All right, so any questions on either of those? Hopefully all of this will come back to you very quickly. All right, we have a lot to go over, and I want to get to the word problems here. So let me just keep on right on moving. Okay, so absolute max and min, we're looking for first derivative. Okay, so now we're done graphing, right? I still entered the graph just so you had a visual of it, what it looks like. But we don't have to do any of the test charts. We don't have to do any of the graphing. All we want is the first derivative, and we need to get our critical points, and then test them. Okay, evaluate, not test, sorry, evaluate. Right, to find the maximum or the minimum. All right, so now we have endpoints. Okay, so remember, absolute max and min will only happen at the endpoints or at the critical points. So that's why everything else we don't have to worry about. We don't have to test anything else except the endpoints and the critical points. So our first step is to find the derivative. Okay, and then we're going to set this to 0 and solve. So I'm going to factor out 5x squared. I end up with x squared minus 16x plus 60 equals 0. And then here's your factoring again. What do you multiply to get 60, add to get negative 16? So it would be negative 10, negative 6. And always double check. A negative times a negative does give me a positive, and a negative plus a negative does give me a negative. So I end up with 5x squared, x minus 10, x minus 6 equals 0. And then I'm going to solve for x. So x equals, and these are our critical points, 0, 10, and 6. And these all fit within our domain. Okay, so now we're just going to test. We're going to find what is our function at 0? Well, when I plug 0, 0, 0, I get 0 out. What is our function at 6? 6 to the 5th minus 20 times 6 to the 4th plus 100 times 6 to the 3rd. And again, I'm just saving time, is 3456. And then when I plug in 10, because 10 is the other endpoint, and it's a critical point, so I'm using it. So 10 to the 5th minus 20 times 10 to the 4th plus 100 times 10 to the 3rd, all of that goes to 0. Okay, so our maximum is at 3,456, and I have minimums at 0 and 10, 0. Okay, and that's it for absolute max and min. Get the derivative, set it to 0, find your critical points, and then evaluate. And we evaluate back to the original function. Okay. All right, again, if I don't hear from you, I'm assuming you guys are good to go. Hopefully you're not sleeping. All right, here we go. So this is our optimization. So this was, remember, this was the peak of all of chapter 11. So optimization means we are looking for maximum. All right, anytime we're looking for maximum or minimum, but mostly maximum, we're looking for the first derivative and then testing it. Okay, so remember, if you remember, we went through all these steps to do this. So hopefully now that you know the process, you can kind of whittle it down a little bit faster. All right, so we're given revenue and cost. X denotes the number of clocks made. That K shouldn't be there. What is the maximum profit? So we're given revenue and cost, we need to find profit. So remember, profit is the revenue minus the cost. So I'll just find the profit function up here. And I'm going to rearrange this. Now, I was going over these with a colleague, and I had done all the work. And he goes, Ellen, a couple of these are wrong. And the reason is because I didn't do 0.025, I did 0.25. So make sure that you pay attention to where the decimal is, because it did make a big difference. All right, so our profit function. So this is, remember, we're looking for the objective. This is our objective. Negative 0.025 x squared. 480x minus 200 is 280x. And a negative 100,000. Okay, there's our profit. All right, the constraint, remember, is already embedded in our revenue. Constraint is the price, so we don't have to worry about that. We're just looking for maximum profit. The endpoints we don't necessarily have to worry about because we were not given the price. Okay, so now we're going to find the derivative. So really what we're doing, once you get your objective, now you're right back to absolute max and min. Now you're looking for the absolute maximum profit. So 2 times negative 0.025 is negative 5. I think. No, negative 0.5. And then derivative of 280x is 280. Now I'm going to set this to 0 and solve. So 280 divided by negative 0.05, my x is 5,600. So here's my critical point. Okay, now since we don't have to worry about endpoints at this point, all we have to do is test our critical point. Okay, so if our critical point is 5,600, I'm going to plug this back into my original function. And I get my profit at 5,600 products is $684,000. That's my maximum profit. All right. And then how many clocks? So remember, X is the number of clocks. So to interpret this, I can do it this way. See if it'll let me type here. Wow. I don't know what just happened. Don't like that. There we go. I'll just write it. Okay, so the maximum profit $684,000 is made when 5,600 clocks are sold. Right? So that's your interpretation. So again, on the test, on the final, whenever you're given a word problem, if you can give me an interpretation, that'll be extra credit. All right, any questions on that one? Okay, so here's another one. This is in doing area, maximizing area. So with this one, it's always a good idea to draw the picture just to give you a visual. So we have a perimeter of 200 feet. So I have length, and width. So my objective is maximized area. So remember, area equals length times width. My constraint, so what holds me back is the perimeter is only 200 feet. So I have 2 lengths plus 2 widths has to be less than or equal to 200 feet. Okay, so now I'm gonna solve for one variable. Divide by 2. So my length has to be less than or equal to 100 minus W. So if you need endpoints, your endpoints are at 0 and 100. Right? If you move this over, if you set this to 0, it has to be greater than or equal to 0. So it's going to be between 0 and 100. So these are our endpoints. Okay. All right. So now we're going to plug our constraint into our objective. So our length was 100 minus W times W. So area in terms of W is negative W squared plus 100W. I just distributed this and then switched it. Okay. So now you're back to absolute max and min. You're going to find the derivative. Set the derivative to 0 and solve. So my W equals 50. And now I'm going to test it. Area at 0, area at 50, and area at 100. Now, if you notice the one that we did before, we didn't deal with the endpoints, and that's okay. The endpoints are just kind of there to keep you moving in the right direction. But this one, because there were no endpoints, I didn't have to test it. All I had to test was the critical points. Where here, because I had endpoints, I'm going to go ahead and test it. But you and I both know that if this is my area and I have 0 width, I'm going to have 0 area. If I have the maximum width, negative 100 squared plus 100 times 100, that's also going to give me 0. So I don't want to say always because that gets me in trouble, but 90% of the time, your maximum is going to be at the critical point. Okay, so 50 squared is 2,500 plus 5,000. So my maximum area is at 2,500 feet. And then we're looking for the dimensions. So 50 is my width. My length is 100 minus 50. So I have dimensions of 50 feet by 50 feet gives me a maximum area of 2,500 feet squared. Okay, so from the very first time we did these till now, you should have a pretty good idea of the process of it, right? Knowing what your numbers mean, how you got the numbers, finding the critical points, and so on. So any questions on this one? Okay, moving on. So this one is a price change. And how do you know that it's a price change? It's because we are reducing the airfare by $5, which would attract 3 more passengers. Okay, so, and we're looking for maximum area, or I'm sorry, maximum revenue. So remember, revenue is the number of products times the dollar amount. Okay, so we have to come up with both of those functions, the number function and the dollar amount function. So this is where you keep number with number and price with price. Okay, so as far as the numbers go, and watch how they throw in extra numbers, the regular airfare between New York and San Antonio is $500. An airline with a capacity of 300 passengers on this route observes that they fly with an average of 180 passengers. Okay, so the value that you're going to use, you have to choose between 300 and 180. Well, we're looking for the actual number of passengers. So yes, the airline can have a maximum capacity of 300, but only 180 fly. So we're going to start at 180. And when we reduce the price, we will attract 3 more passengers. So plus 3 more. And remember, X is the number of changes with the price change formula, or with the price change type problem. And then the dollar amount, just look for the dollar sign, 500. And we are reducing by $5. So minus 5 times the number of changes. Okay, now we're good to go. We have our number and we have our price. So our revenue in terms of X is 180 plus 3X times 500 minus 5X. And then we're going to keep going. Now we're going to simplify it, right? We're going to do FOIL. So 180 times 500 is 90,000. 180 times negative 5X is negative 900X. 3X times 500 is 1500X. And 3X times negative 5X is negative 15X squared. So my revenue function is negative 15X squared. 1500 minus 900 is 600. And then plus 90,000. Okay, so there's our revenue. There's our objective function. That's what we're looking for. So now we're right back to absolute max and min. Going to find the derivative of that. Set that to 0 and solve. So our X equals 20. So again, remember, you can do this either way. You can factor out a negative 30 and get X is 20, or you can move the 600 over and divide by negative 30. Either way works. So either way, you'll get 20 as your critical point. Okay, so then we're going to evaluate. So when I plug 20 into this original function, I get 96,000. Okay, now again, this is not 20 tickets or $20. This is 20 times that I've changed my price. All right, so in order to, this is our maximum, this 96,000 is our maximum revenue, but then it also wants to know what's the price and what's the number of passengers. So then I have to go back up to my original 2 functions. So to find the number of passengers, I plug in 20. And 180 plus 60 is 240 passengers selling for $400 each. Okay, so 240 passengers. Oops. Okay, selling 240 tickets at 400 each gives maximum revenue of $96,000. Okay. So sometimes lowering the price is a very good thing because it draws in more customers. So again, this is a price change problem. Any questions on this one? All right. So this is the last kind. Nope, sorry, not the last kind. So this is that candy box one. You made it out of a piece of cardboard, measure 12 by 12. Squares of equal size will be cut out of each corner, and then the ends and sides will be folded up to form a rectangular box. So the picture of this is we have a square piece of cardboard and we are cutting out the corners, right? We're cutting out a square out of each corner. This is a 12 by 12. Okay, so remember when we fold those up, when we fold up the flaps, that what we cut out, this X that we cut out, is now the height. So we're going to have our length is 12 minus 2x. Our width is 12 minus 2x, and our height is x. So in this case, we're looking for max volume. So remember, our objective function is length times width times height. Okay, so now you have all the information. You no longer have 3 different variables. Now you've rewritten each variable in terms of x. So my volume is the length times the width times the height. Okay, and now you're just going to multiply all this out. And to save some time, I've already done that. And I get, oh, there it is. I get 4x cubed minus 48x squared plus 144x. Okay, that's all of those 3, the 12x minus 2 times 12x minus 2, and then that answer times x gives you the 4x cubed minus 48x squared plus 144x. Okay, and now you're right back to absolute max and min. You're going to find the derivative. We're going to set this to 0. So I'm going to divide out an x or a 12. And then what do you multiply to get 12? Add to get -8. So it's -6 and -2. So my critical points are x is 6 and x is 2. Okay, so I have 2 critical points. So I'm finding the volume at 2 and the volume at 6 to find which one is the maximum. All right, now if I plug 2 in, remember we're going back to this original, always take it back to the original when you're evaluating. So 4 times 8 is 32. 48 times 4 is, what's 48 times 4? 192 plus 144 times 2 is 288. So this maximum volume is 128. And then I have to plug in my other critical point into here. So 4 times 6 cubed is 864. And then 48 times 36 is a -1728. And then 144 times 6 is 864. So all of this ends up being 0. So this is our max volume. Okay, so what size squares should be cut from each corner? The width is a 2 by 2, right? Because the x is the same. So our length is 12 minus 2 times 2, which is 8. Our width is also exactly the same, and our height is 2. So 2 by 8 by 8 gives us 128 inches, yeah. So we have an 8 by 8 by 2 gives us 128 inches cubed. These are our inch signs, our little double apostrophes. Okay. Any questions? All right. I'm gonna skip this one. You guys will have this one. I have the answer. This is just another price change. So you can take a look at it just to save us some time. But this one, I just wanted to kind of set it up for you because you may see this in the test. So a homeowner wants to enclose 4 adjacent rectangular pins of equal size. What is the largest total area that can be enclosed using only 480 feet of fencing? So this distance here is my length. This distance here is my width, but I have fencing here, 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 and then again here. Okay, so this is why it's really important to always draw a picture because it gives you a visual of what you need. All of those sides has to be 480 feet. So I have 2 lengths plus 1, 2, 3, 4, 5 widths has to be less than or equal to 480 feet. And then my objective is length times width. So I'm going to solve this for W. Divide by 2. So I wanted to show you this because I wanted you to see that you don't have to freak out if you have a fraction. So 480 divided by 2 is 240 minus 5 divided by 2. We can write it since it's a what's a terminating decimal. You can write it as a decimal or you can leave it as 5/2. Either way works. So there's my length. So now I'm going to plug that into my objective. And then just simplify. Okay, then you can go from there. All right, and I'll write down what the width and length are. All right, so we have it. Well, I'll just keep going. I think we'll have time. So 240W minus 2.5W squared. So I'm going to find my derivative. So 240 and then 2 times 2.5 is 5W. So my W is going to equal, where it is, 48. 240 divided by 5. So now we are right back. So this is our original objective function. Now we're right back to plugging it in. So area at 48 gives me 240 times 48 minus 2.5 times 48 squared. And that ends up being 5,760. Okay. So I know my width is 48, my length, I can plug it back in here. So my length is going to be 120. So my dimensions are 120 feet by 48 feet, gives a maximum area of 5,760 feet squared. Okay. So these objective functions, those are the ones, or optimization functions. Those are the ones that kind of tripped you up a lot. So what I would say is go back over these. This is in Canvas. Go back over these and do them on your own several times to get real comfortable with those. Any questions?
No.
All right. Okay. So the last thing that we got to do is you still have section 12 and 13, which is the last couple weeks that we went over things. And so what I'm going to do is I'm just going to do 1 or 2 in each section. Remember, there was 4 different sections that we went over. And I have it separated out on the final. So it's not embedded within. You're going to do the final, and then at the end, we have these two sections to do as part of the final. So hopefully that will keep it clear, because again, the biggest mistake that I see people make is they don't keep the derivative separate from the antiderivative, right? So the derivative, you do one technique, the antiderivative, you do another technique. Okay, so for when you're doing these, the indefinite integral, don't forget your plus c. All right, how do you know it's indefinite? Because there's no numbers top and bottom. You have your integral sign and there's nothing, no endpoints, no place that you're going to evaluate. So that's how you know you have to do the plus c. So as you're walking through these, remember the process, right? Antiderivative, you're doing the opposite. So when you have a number by itself, you're going to add an x, right? We're adding 1 this time. We're going to add 1, divide by my new exponent, add 1, divide by my new exponent. So even as I'm going through all of these, I still do this, even though I know I'm adding 1 and dividing, but it gives me a visual. It gives me something to look at so I can go, okay, I got this. So this is the derivative. We are looking for the antiderivative. So we're looking back to the original function. So 4x minus 15 over 2x squared minus 8 divided by 4 is 2x to the 4th plus c. And that's all you got to do. Okay. And then on B, you have your e. So e raised to a function. So remember, the antiderivative of e raised to the function is you're going to divide by the derivative. So it's kind of a combination, and then repeat your e function. Okay, so when I look at this, the derivative of 0.25x is 1 over 0.25 times 16. So don't forget that 16 has to stay. And then e raised to the 0.25x plus c. So now I can just simplify this. So another way that I could write this is 16 over 0.25. It's the exact same thing. So 16 divided by 0.25 is 64. So this becomes 64 e to the 0.25x plus c. Okay, so either way you can write it. Okay. And then I'm just going to rewrite this, and then we'll move on. So remember, a radical, you cannot find derivative or antiderivative of a radical. So all I'm doing is I'm rewriting this. This 3 comes underneath, so it's 7/3. Also cannot have a radical, a fraction to find the antiderivative. So we're pushing that x to the -7 up. So it's minus 6x to the -7. And now you can find your antiderivative. You add 1, divide by your new exponent. So I'm going to add 1 and divide by 10/3. Here I'm going to add 1 and divide by a -6. So I end up with, remember, you flip it and multiply. So 3/10 x to the 10/3 plus x to the -6 plus c. And then this one, I'm adding 1, dividing by my new exponent. Here, if I do that, you see I'm dividing by 0. So there's your red flag, right? Anytime you divide by 0, you have a problem. So what that means is when I have the antiderivative of x to the -1 or antiderivative of 1 over x, this is always ln of absolute value of x. Okay, so this one becomes -1/8 x to the -8 plus 9 ln of x plus c. Okay. So I thought this was a good word problem to kind of help us transition. So a patient's temperature is 104 degrees Fahrenheit. It is changing at a rate of T squared minus 3T degrees per hour, where T is the number of hours since taking fever-reducing medicine. So they want us to determine the function. They give us the derivative. They want us to find the function. So we are going to find the antiderivative in terms of T. So we're going to walk through the process, add 1, divide by my new exponent, add 1, divide by my new exponent. So I end up with 1/3 T cubed minus 3/2 T squared. Okay. And then all they want to know is what's the patient's temperature after 3 hours. So once I have this function, now I can plug in my 3. So the minute I have numbers to plug in, I don't have to do the plus C anymore. So I have 1/3 of 27 is 9. 3/2 of 4 is 27/2, sorry. Is that right? That's not right. Oh, I see what I just did. You guys need to catch me. 3, not 2. There we go. I thought, why is that not working right? So 3/2 of 3 squared. So 3/2 of 9 is 27/2. So this ends up being -4.5. So what that means is the fever reduces by 4.5 degrees after 3 hours. So if it started at 4 or started at 104 minus 4.5, you're now at 99.5 degrees Fahrenheit. Okay, so this is how much the temperature drops. Okay, and then I'll just do one of these. So now we're at the definite integral. How do you know it's definite? Is because you have values, right? So now we can evaluate. So this one again can't have a radical, also can't have a fraction. So this becomes the antiderivative between 9 and 1 of 3x to the -1/2. So remember, this ends up being 3 over x to the 1/2. Remember, there's a 2 here and a 1 here. And then when you push that up, it becomes 3x to the -1/2. Okay, now I can find the antiderivative. So I'm going to add 1, divide by my new exponent. So flip this over and multiply. So 1/2 flipped over is 2. So I end up with 6x to the 1/2. And now I'm going to evaluate that between 1 and 9. So 6 times 9 to the 1/2 minus 6 times 1 to the 1/2. So remember what the 1/2 is. 9 to the 1/2 is the same as the square root of 9, which is 3. 1 to the 1/2 is the same as the square root of 1, which is 1. So I end up with 6 times 3 is 18. 6 times 1 is 6. So my value is 12. Okay, so I'm just going to do that one so we can get to the Gini index and the consumer and producer surplus. Okay, so remember Gini index. The formula is 2 times the antiderivative of x minus the function. And it's going to be between 1 and 0. Oh, I'm sorry. Oh, that's down here. I'm so sorry. Hang on. I'm jumping too far ahead. Thought I was doing Gini index. All right, so area between the two curves. I'm just going to set this up. So we have two curves, and I will give them to you in order. So this is the top, this is the bottom. So remember, area between two curves, you just subtract the two functions, right? And then you simplify it. So you end up with x squared minus 2x, and then 1 plus 2 is 3. And then you're going to do what we just did, find the antiderivative, and then evaluate. All right, now we can do the Gini index. So Gini index is x minus the function between 1 and 0. Okay, and like I said, you can go back to this later and try the other ones that we're skipping just because we're running out of time. All right, so for 1929, our function is x to the 3 halves. So it's going to be 2x minus x to the 3.2. So I'm going to add 1, divide, add 1, divide. So don't forget that too. So 2 times 1 over 2 x squared minus 1 over 4.2 x to the 4.2. And I'm going to evaluate that between 0 and 1. Okay, so again, I'm going to save this 2 for the very end. So I have 1/2 times 1 squared minus 1 over 4.2 times 1 to the 4.2, which equals 1/2 minus 1 over 4.2. Where am I? Which is 0.2619. Okay, that's what all of this is. And then when I plug in the 0, it just goes to 0. So I'm going to take this and multiply it by 2. So I get 0.5238. Okay, so this one is the 1929 Gini index. Right, now the other thing you need to remember is the closer it gets to 0, then that means that the income is distributed more evenly, the closer it gets to 0. So now, then in 1935, they did some changes. So in 1935, our new function was x cubed here. So again, add 1, divide, add 1, divide. So I get 1/2 x squared minus 1/4 x to the 4th, again, evaluating between 0 and 1. So 1/2 minus 1/4 is 0.25. And then don't forget to multiply by 2. So you get 0.5. Okay, so 0.5 is less than 0.5238, which means the changes that they made, 1935 was more equal distribution, income distribution. This was 0.5238, and this was 0.5. Okay, and again, you don't have to memorize the formula. The formulas will be given to you. Okay, last one. We have consumer surplus. So consumer surplus between 0 and the x is the demand function minus the price. And then producer surplus between 0 and x is the price minus the supply function. So remember, if you have this visual, here's my supply function, here's the price, here's the demand function. Okay, so consumer surplus is up here, producer surplus is down here. Okay. All right, so here we go. Between 0 and 200, because they gave us the X, the demand function minus the price. Price is what we don't have, so we have to find it. So remember, the demand is the price function. So we're going to go 300 minus 0.5 times times 200. We're just plugging X into there to get our price. So 300 minus 100, our price is also 200. That's not going to always happen. The price and the X isn't always the same. It just happens to be with this one. Okay, so now it's just different, the area between two curves. You have the demand curve and you have the price curve. So you're just finding the difference between the two. So we end up with 100 minus 0.5x, evaluating between 0 and 200. And add x. Go through our antiderivative, and we get 100x minus, so 0.5 divided by 2 is 0.25x squared, evaluating between 0 and 200. So again, I'm sorry, I'm running out of time. To save time, it's 10,000. So all of this up here means our consumers, we saved our consumers $10,000. Okay. And then the last one, again, we have 0 to 200. We have to find the price. So we plug the X into our supply function and we get 0.4 times 200. So our price is 80. So with this one, we're going to go 80 minus the supply function. And then we're going to find the antiderivative. So we get 80x minus 0.2x squared, evaluating between 0 and 200, and we end up with 8,000. So that is our producer surplus, right? Our producers were willing to pay less or willing to sell it for less, but we didn't have to, so we made a profit. So remember, producers is basically our profit. Oh, made it. Okay, I know that was very, very fast. Very, very fast. But like I said, all of this should just be review. It should just be like, okay, that's right. I remember how to do that. So please, if you have any questions on the ones that we didn't do, or if you have questions on the ones that we did do because I went too fast, please reach out to me and ask. And other than that, I will see you guys on Tuesday for your final exam, and then we are done. Have a good weekend, you guys.
Bye, Miss. Thank you.